Hi there, this is video C.C3. We're still talking about the fundamental accounting principle. And as I kind of hinted, we really have to watch the vocabulary. So I'm going to try talking about independent and dependent decisions, which is something I was reading about it over the summer, trying to figure out the best way to teach this. So we're going to try this out. So independent decisions. The results of my first decision do not affect the results of another decision. Okay, so whether I have Diet Coke for lunch isn't going to influence whether you are on time or not. Those are two independent things. By the way, independent and dependent also comes back in the next chapter, and it becomes really important. Dependent decisions, the results of one decision do affect the results of another one. So whether or not I had Diet Coke for lunch is going to influence how hyper I am in the afternoon. Okay. If you show up late for class, that decision might influence my decision to hassle you a little bit about being late for class. Okay, so what I want you to do first is I think I'd like you to pause the video, and I just want you to read through these questions and just take your handy dandy highlighter and find the differences. Okay, can you do that for me, please? So pause the video. All right, so I'm not even going to worry about independent and dependent right now. Let's just see what's the difference here. So there are 15 students in the class. At the end, they're getting awards. If a student can win more, okay, so these guys can win more than one award, and these guys cannot win more than one award. A new highlighter. All right, so let's take a look at the next one. I don't care about the answers right now. The numbers 2 through 4 and 2, 3, 4, 5, 6, and 8 are used to make up a code for the copy machine. A number can be used more than once. How many codes can be made? Okay, so it looks like number more than once, and I suspect over here it cannot be. Okay, I'm not too creative with these questions. How many different license plates can be made that consist of 3 letters followed by 3 digits? Okay. How many different license plates can be made that consist of 3 different letters followed by 3 different digits? Okay, so sometimes it's really in your face and says you can use it more than once, or you can do this more than, or you cannot. Sometimes it's not. If it doesn't say anything, so if I gave you this on a test, I'd probably be cursing myself afterwards because it's not clear enough to me. This one I would read that you could use a letter more than once because it doesn't say you can't. Okay, whereas this one it clearly does. I try when I give you assignments and stuff to make it clear. Okay, so independent decisions, dependent decisions. Yeah, let's do the questions and see what happens with the answers. Okay, I'm going to do one. I'll do the top one, and then I'll let you do the other ones. All right, so we have 15 students in the class. At the end of the year, awards are given out for attendance, leadership, academics, and most improved, and that's actually what we do give awards out for. If a student can win more than one award, how many different sets of students can win? Okay, so we have attendance, leadership, academic, most improved. So for our first one, attendance, there are 15 students. Now it says a student can win more than one award. So Skippy won the attendance award. Could Skippy also win the leadership award? Yes, because it says students can win more than one. Okay. And you know what? He could win the academics because he could win more than, theoretically, there's nothing banning that from happening. Now, in the real world, I've never seen that happen. But quite often, attendance and academics are won by the same person. All right, so we got 15 times 15 times 15 times 14. Ah, no. Five, 0, 6, 2. All right, now, same question-ish, close. 2, 3, same awards. Attendance, leadership, academic, most improved. All right, so 15. Now, this question specifically says a student cannot win more than one award. So that means when it comes to leadership, if Skippy won this one, Skippy can't win anything else. So whoever won this isn't in the running anymore. So that means there's only 14. So now we've handed out attendance and leadership. Those two people can't win anymore. So that's going to leave us 13. And I think you can see the pattern, 12. So let's see that, 15. Oopsies, 32,760 different ways. Okay, so what I want you to do, and I think you can do these ones and these ones, and then we'll talk about this last one. You can try the last one too. So pause the video. Pretty sure I say this in every video, or at least every second video. If you just watch the video and copy exactly what I'm doing, you're not going to learn very much. You need to try them on your own. Do it in pencil. Oh, which reminds me, I should be doing these in pen. Sorry. I got told you can't see my pencil very well in the videos. All right, but you want to try, because when you go to do the assignment, or more importantly, when you go to write the test, there's nobody, if you wait long enough, that's going to tell you how to do it. So you got to try. Okay, so pause the video. Oh my goodness. Hi, you're back. Okay, so on this one, on a test, it's not the greatest because I probably should have said how many numbers in the code, but we'll just say that there's 1, 2, 3, 4, 5, 6. All right, so 6 blanks, why not? 1, 2, 3, 4, 5, 6. Okay, so that was my mistake on this question. I should have said that the code is 6 letters long, or 6 numbers long, or 4 numbers long, or something like that, but I forgot to say that, so we'll just say 6. Now, if we can use it more than once, that means I have 6 choices to begin with, because, hold on, 1, 2, 3, 4, 5, 6, yes. And whatever I use, you know what? I can reuse it. So 6 all the way along. You guys familiar with that button? That is the same as the Y to the X button, and it saves me going 6 times 6 times 6 times 6 times, however, I've lost track already. 46. I'm going to put a star there so that when you actually get your copy, it'll be corrected on. All right, so 1, 2, 3, 4, 5, 6. So this means, by the way, your code could be 2, 2, 2, 2, 2, 2, or a bunch of 8s or a bunch of 6s. Doesn't matter. Now, this says if a number cannot be used more than once, how many codes are there? Well, when I pick my first number, there's 6 choices, but let's say I make that first one a 5. So that's gone, which then leaves me 1, 2, 3, 4, 5 left. And then let's say I use that one. So 1, 2, 3, 4. And if I keep crossing the numbers off, 3, 2, 1. Sorry, I'm looking for a mat. Oh, there it is. All right. 6 times 5 times 4 times 3 times 2 times 1. 720. I'll show you guys magic. You go 6, and then look. Can you see in the calculator? See that little X and the exclamation mark? That is a cool button. That's called factorial. We're going to use it again later, but if I use that, I say factorial. You might say exclamation mark, but it's factorial in math. I hit the equals. Oh, you can't see it, but no. Where am I going to go? There. It did it all at once. I didn't have to multiply it through. Not that multiplying 6 times 5, all of that is that difficult. But if that were like 15, that's a lot of work, and I'm like screwed up, so I want to do that. Anyway, so that's factorial. Again, we'll come back to it later. And it's the x. It's either an x or an n. Do this. Right there. Exclamation mark there. Very, very cool. Very, very useful. All right. How many different license plates can be made consisting of 3 letters followed by 3 digits? So letter. Whoopsies. Digit. All right, first question. I'm going to tease you. How many letters in the alphabet? English alphabet. Exactly, 26. And it doesn't say anything that I cannot repeat things, so I'm going to say there's 26 and 26. So it could be A, B, B, or A, or C, 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 whatever. Now, digits. How many digits are there? This is one people get mixed up the first time. There are 10, because you've got 0 to 9. So you include 0 in that, you need 10 times 10 times 10. So 26 times 26 times 26 times 10 times 10 times 10. And yes, if somebody is thinking, why didn't you just multiply by 1,000? Yes, that would work too. Oh my. 17, 5, 6, 7, 0. All right, you don't need the commas in there. I put them in there. Yeah, you're going to find the answers in this section are going to be big. And that's okay. Oh, wait a minute. I just want to show you something. I just randomly picked a number. Can you see? If all I had is that much on my calculator, I would assume I screwed up because I shouldn't be getting a decimal point. But if you can see right there, little itty bitty, it says times 10 to the 12th. Okay, so scientific notation. So if this is my answer, I'd write this, then I have to write the times 10 and the 12, and I'd be fine. Okay, let's get rid of that though. Now, how is this one different? Okay, because it's asked for different letters and different digits. So it's still letter, and digit. So first choice, 26. But then I've used a letter. Let's say I've used J. Can't use it anymore because it has to be a different letter. That should be 25. And then exactly 24. And the same similar here. I start with 10, and let's say I've used a 7, which would lead me 9 to work with, and then it would lead me 8. So in general, if you can't repeat stuff, your answers are going to be way smaller. That should not be much of a surprise, right? 26 times 25, 4 times 10 times 9 times 8. All right, so this time we have 11,232,000 different license plates. Whereas if you can repeat, then you've got 17 million. So a lot more. All right, last question. Which type of question is it? So I guess I should ask this question. So dependent decisions. No repetition. I would like you to write that on yours. These ones, repetition. Allowed. Okay, let's look at their last question here. In Florida, standard license plates follow the pattern 3 letters, 2 digits, 1 letter. Okay, such as TRR 47R, BNW 22, ZQW 95M. How many different plates are possible? Well, so we've got 3 letters, and then a digit, and a digit, and a letter. But the question doesn't say whether I need to use the same letters or whether I can't. And that's where pay attention to what the examples show you. So you can see here, we got TRR, another R over there. It looks like it doesn't matter with the letters. You can repeat them if you want. So that means 26, 26, 26, and we're even going to put 26 down here on this one. Okay. If the example showed them to be all different, then you'd be okay with going 26, 25, 24, 23. Okay. Or at least you'd have an argument with me about that. But I specifically put these in here to show that, yeah, you can repeat your letters. And for my digits, all right, what do you think? Can I repeat or not? Yeah, it's right there. I tried to show you in that one that that was okay too. So that's 10 times 9. Whoops. Oh well. I went 1, 2, 3, 4 on there times 90. I'm being lazy. Whoops. 90. There we go. So write that down. 41, 1, 2, 7, 8, 4, 0. Okay, so this one was independent, by the way, because I was allowed to do repeats. And you could have questions that you're allowed to repeat, you're not allowed to repeat. You can only repeat the letters, but you can't repeat the numbers. You can repeat the numbers, but not the letters, right? There's an awful lot of different choices you can have there. So it's all about reading the question. So take your time, use your highlighter. It's all good. You know what? I was doing this myself and maybe on a test or something. I might even do something like that. So I highlight that part because that's the important part. All right, end of the video. Thank you for watching.